No.
We're on the air now.
Yeah, so when I use remove key from main, it works.
Oh yeah.
But when I put the one from insert, doesn't work. So
All right, let's do this. Let's do it.
okay.
Who's sharing? I guess I'm gonna open it on Drive.
Ryan, where do you live?
Oregon?
Central Oregon?
Yeah. In Bend.
In Bend? You guys gonna get a university campus out there, you think?
I'm off to Walmart.
No, we are getting one. The land's already been bought.
So we're on worksheet 37?
Really? 40.
40?
Isn't it 40? And we had to turn in 40, 41, and 42.
Oh, I was looking at the wrong week. Hold on. So it's week 8.
Week 9.
Oh, week 9. $40. All right, they're all in the Drive thing. Okay, got it open now. Wayne, can you see it?
I can see it on my computer, my drive. That's good enough.
I think all you guys can see it.
Where's everyone else this week?
Christian's gone rogue on us.
Yeah, he hasn't been around in so long.
So this first part, Wayne, you did it. I don't even know how it works.
The table?
Yeah.
Yeah.
These are the
Fifty
NBA live from the Western Conference Final.
My bad. My stream was still on. Anyway,
So if you look at the map up above, what is the first one? The first line is Pendleton, right? So from Pendleton points to Phoenix, and it points to Pueblo. Phoenix has a value of 4. Pueblo has a value of 8. So in the table, Phoenix, which is number 3, gets the value of 4, the weight of its edge. And the other one, 7, is Pueblo, and it gets the value of 8.
why is there a value of 1 in Pendleton?
Oh, because
Should be 0, right?
no, I'm trying to tell you why, but I can't quite think of it. I know
Oh,
they're
wait.
all 1 though. They're all
Those were the ones that were already in there.
yes, yes, and it's like it's a self-reference, Pendleton, and up above is Pendleton as well. So
Yeah.
that's why it's in 1 there.
Okay, well, the rest is straightforward. I follow.
Wait, is this like discrete math?
It's a lot like discrete math, isn't it?
Is it?
Yeah. These are this Dijkstra's algorithm and all of this stuff is a lot like the mapping we did at the second half of discrete math. So that's all there is to that table. It's not really too complex.
Yeah, and the one below that, where we just have the edgeless representation, pretty straightforward as well. Like from Pendleton, you can go to Pueblo and Phoenix, and you just have the weight next to them.
It's the same information.
The same.
Yeah.
Yeah, it's just written in a different way. So I don't know if you guys have questions, or we can move on to the next one.
Let's go to the next one.
All right. Haven't looked at this since I did it. Okay, so this is the. Oh yeah, this one is I feel is a little involved. The depth first search and breadth first search.
I haven't done this one yet.
So I did this one. I'm trying to figure out a way where I can look at the. It's hard for me to like step you guys through it if I can't look at the visual thing at the same time.
So we're supposed to do this as a depth first, is that right?
Yeah, the first one is the depth first search. Like I have a table in there. Are you guys looking at it?
What? Where? I'm looking at the wrong. Oh, there it is. I see it. Okay.
You see it?
Yeah.
I'm trying to pull up. I have my other computer here. Maybe I can just pull up the chart on that one, and then I can like talk through it.
Hard to do without the diagram in front of you, isn't it?
Yeah.
As I think about doing these on the test, it's going to be hard for them to test on all of this material in the time limit that they have. Because think about how long it takes you to step through one of these, for example.
Yeah, this one in particular is like, I mean, you
time-consuming.
have to think about. If you don't, I mean, unless you really know it, like you have to think about it a little bit and like make sure your logic is right.
Right?
Well, this test has 110 minutes.
Yeah.
compared to the 120 on the last one.
So it's shorter.
Yeah.
All right, so I have it open. So I think that the main difference between the depth first search and
What are we on?
depth and breadth, but the main difference to know is that in a depth first search, you kind of you explore like one area at a time.
Uh-huh.
Like you go with one direction at a time, and then in a breadth first search, you're actually trying to crawl like every single possible direction at once. And you'll kind of see that as I try to step through it, but I don't know if you guys are able to look at the diagram while I talk through this. Otherwise, it's kind of hard.
I don't, but I'm going to make myself.
Maybe you can try to paste it in. I don't know what to do about
That's
it.
what I'm going to do. I'm going to try to capture it here. Green capture the thing.
Are you trying to put it in, Wayne?
Oh, it's not going to let me do that. Hold on.
Yeah, you gotta maybe take a screenshot of it and then put it in,
That's what I was thinking.
because it's a really strange, like the way they have it in there is really strange. That kind of works. I mean, I think that works.
Yeah, that'll work for me.
Anyway, so starting at number 1, so you're in the upper left corner, and then you go, and now I'm losing myself. Hold on.
Doesn't matter whether you go to
Doesn't matter whether you go to the bottom or to the right.
where it doesn't matter.
In this case, they went to the bottom first, and they stacked the 6 on the top, and then from 6, 11 is reachable. Well, actually, if you start at 1, right? If you start at row 1 and then you go here to 1 in the middle where it says stack, then 1 is reachable. So you move 1 to the upper right cell next to that. So where it says reachable, you add a 1, and then from that 1, you can go to 6, or you can go to 2. So that's why they have 6 and 2 in the stack. And then, but they decided to go to 6, so that's why they brought the 6 in row 3 over. And then from 6, you can go to 11. And so then, but the 2 is still in the stack. You see how that works?
Yes.
And then from the 11, then they decided to go to the 11. So then from the 11, you can go to 16 or 12. So you add those to the stack.
So
You need
once they decide to go there, it goes over to the reachable.
Yeah, once you decide to go there, it goes over to the reachable.
So 11 goes over, but not 2.
11 goes over, but not 2.
Okay.
2 stays in there, like as you can see, because on the bottom of the stack, like basically the whole way down. Trying to pick some areas where it gets interesting, like from, let's see, from 21. No, that's pretty straightforward. I want to pick somewhere where you get stuck. Oh, so in row 8, on the depth first search, at 23, you can't go anywhere because you're stuck. You see that? You see how it's a dead end?
Yep.
So what they basically say is, well, 17, 12, and 2 were already in there. So you come into the middle of the row, like you come over here, and then you just go, and then you try from 22 to go to 17. So then 17 goes into the reachable. So that's like the main thing to know, what happens when you get stuck in a corner. Otherwise, you just like traverse the entire thing. And actually, in the solution given, and even on this one, I didn't finish it because it's really long. Even these 12 rows does not traverse the entire diagram. I don't think we have to. You just have to demonstrate that you know how to do it.
Who knows what they're going to ask on the test? But yeah, I think you've done more than enough here. Let me ask you, on 23, does that get put on the stack? I mean, in the reachable?
Well, yeah, 23 is in the reachable right here.
Even though it's a dead end, it's still reachable.
It's reachable. It's just from there you can't reach anything else. So
then you go back. Okay.
Yeah. Do you notice from 7 to 8 your options go from 4 to 3?
Let's see.
So you're so from right here to right here.
I see.
You're limiting your options, and you're supposed to go until you can't go anymore in the stack right here.
Wait, where are you, Ryan?
What was that?
Where?
Oh, I'm saying like after you go from 12, 13, 14, these numbers diminish because from here we're growing, because we have more options as we go further into the maze.
Right.
But when we go down and start filling up the maze, then our numbers might get bigger again, but you're going to notice that these are just going to start shrinking down.
Yeah, okay, so I have a question for you on 10 and 11.
Yep.
In 10, it shows that 12 was put into reachable, which should have taken it off of the stack, right? But it's still in the stack. So it's in the stack and it's in the reachable on line 11.
Yeah, I think it's because 12, if you look at it, so if you go to row 4, right? In row 4, 16 and 12 are reachable from 11, right? That's why they got put on the stack.
Okay.
So then later on, I think it's because we have 17, so we added another 12. In row 9, from 17, 12 is reachable. So then you end up with 2 12s. You see that?
Yep.
The reason that we end up with 2 12 is because 12 is reachable from 2 different areas of the maze, and we never took it off the stack the first time we put it in. So then you are able to add another 12 onto the stack because it's reachable from another point in the maze. And when you take one of them off, the other one is still there.
Okay. In the video, he put Pittsburgh or one of the cities on twice, and it's the same deal. So that's a good explanation.
Yep.
I got it.
You want to go on the breadth first?
I think so.
All right. Can we bring that diagram down? Somebody want to try?
Down.
Wait, where are we?
Ah.
I know you don't like things where we're not coding. That's why you're being quiet.
I'm still doing a remove key.
I knew he was. Oh, what is the matter? Being all weird.
Hey, wait.
Is that all right?
Disappeared? He just disappeared.
Is that too much in the way, do you think?
Oh, he's not here.
He's not?
Oh, he's back.
I got kicked out temporarily. I don't know what happened.
Is that okay where it is, Zach?
I'm coming down. Yeah.
Oh, I found the bug in remove key.
You found it. Yoo-hoo!
Actually, it looks really weird for some. Hey, wait. Leave it. Put it back, Wayne.
Put it back.
That's fine.
Okay.
Oh, we have 2 of them now.
Really?
Can I just have one?
What the hell did I do? Why are there 2 of them? Oh, we got like multiple of them here. It's just a lag.
No, I'm messing with you guys.
Ryan.
I knew that was you, Ryan.
All right, we're good to go.
Let's go.
Okay, let's do it. So this one, like I said, the breadth first search, you try to traverse like the whole maze at the same time. So starting at 0,
A 1?
oh, why do I have 0? No, we started 0. Mm, I don't remember why I started 0 in this one. So let me just start at 1. So from 1, obviously 1 is reachable. 2 and 6 are, oh, I guess the difference is, oh, thanks for the help. So from 1, 2 and 6 are reachable. So then we choose to go to 2. And then from 2, 3 and 7 are reachable. But you see we put them on the bottom of the stack instead of the top.
Okay, yes.
Okay, and the reason we do that is because we now want to go to 6. And we want to go, and so instead of going in that one direction and going to 3 or 7 like we would have done in depth first search, we want to go to 6 because we're trying to traverse the whole maze at the same time. So you always oscillate back and forth in this one. That's the thing to know. So then we, from 6, we can reach 11. So we put that on the bottom of the stack. Now we're going back to the other side to our 3 or 7. In this case, we go to 3. So then 3 is reachable. From 3, we can reach 4 and 8. So those go to the bottom of the stack. We go back to the other side again. We go to 7. From 7,
Nothing's reachable.
we can't reach anything. So 7 comes into reachable, and then we go to the top of the stack again. So we go to the other side again to 11. So it's pretty straightforward. You just, in this one, I would say the other thing to know about breadth first search is that, well, you can choose any direction, but the way you oscillate back and forth is going to be the same. So when in the very beginning, when we decided to go from 1 to 2, I believe we could have gone from 1 to 6 instead of starting with 2. You know what I mean?
Yes.
So then you would have started oscillating from a different point, but that would be the same throughout. The only thing that would be different is like where you started. Whereas in depth first search, I feel like when you choose a different direction, like it's an entirely different path. We can all have different answers on a depth first search problem and still be right, basically.
Yes.
But I feel like the only thing that would be different on a breadth first search, if we got asked a question about it, is like that very first step, if you had 2 options, could be different. But other than that, it should look the same.
The questions on the final preview, they tell you to go a certain direction so that they can try to get your answers all the same.
Ah.
So.
You saw that in there already?
Yeah, I did. I remember one of the instructions saying that go this way.
It makes it easier for them to grade. So
I'm sure it does. Yeah.
So that's really it.
I remember doing this one. Okay.
And the only thing I would tell you guys to look at is those edge cases, right? Like when you get stuck in a corner in the maze, what happens? Just kind of know that. And front of the stack versus back of the stack, like where you put the reachable stuff. That's.
So in the breadth first, there's no backtracking.
In the breadth first, there's no backtracking. What do you mean by that?
In the depth first, if you hit a dead end on your, solo search, right? If you hit a dead end, you back up.
I would say the difference is in the breadth first, that backing up, is actually part of it. Like you are going back and forth anyway.
I see.
Whereas in the depth first search, you're just trying to go forward, and you only go backwards if you hit a dead end. But breadth first, you're constantly trying. at the end you should have touched every point.
Right.
You're trying to. That's what you're trying to do.
Okay.
If you watch the video on it, I think it shows you how it fills them up differently.
Yeah, it does.
But that's really it. I don't think there's anything else to know on this one. We can go to the next one. 42?
Yep.
Let's see here. We didn't do this part, did we? Up here? I don't think so. We did this one.
Oh, I don't remember.
I think we just did the bottom table.
Yeah, but even if we had to do this table, it's not too tough. All right.
It just doesn't look like one I did, that's all. Like, why is there a picture over it? Is that you playing around again, Ryan? So, should we go through the first? Like, I don't get it. Is there an actual question in the top of this one?
No, it's just info.
Okay, so let's go to the bottom. This is Dijkstra. Wayne, do you know anything about it? Like, I don't know what to introduce about Dijkstra's other than like walking you through how it works.
There.
It accumulates costs.
It's basically the same thing as the previous one, but you're just combining the two.
And in this one, they actually tell you where to start. Like, this one says, simulate Dijkstra's algorithm, but this time using Pensacola as the starting city. Okay, now I remember. So the other one used, I guess, Pierre as the starting city. And so in Dijkstra's, you'll get like different outcomes based on like where you start in the diagram.
Right.
So I guess we'll start at the bottom one. So starting at Pensacola, from Pensacola you can go to Phoenix, and Pensacola is reachable to you because you start there with 0 weight, and then on the way to Phoenix you have a weight of 5. The thing that you have to know about this one is that you actually have to like got a lot of noise.
Oh wow, he's here.
Yellow shirt.
Is your internet not working again?
What's that?
Christian, can you mute?
Yeah, sorry.
Thanks.
I'm trying to be serious right now and explain this.
All right, back to it. So from Phoenix, you can go to, let's see what are our options. Looks like we have 3 different options. Pueblo, Peoria, and Pittsburgh.
Really?
But what you have to do is, I believe you have to add the weight of Phoenix to each of those. So from Pittsburgh,
Yes.
weight of 10 to go there, so you add 5 and you actually get 15.
That's the whole gig, is that the Dijkstra accumulates. So
Yeah.
it adds the previous ones. Gives you the value of the shortest path.
Yeah, and so each time you're supposed to take the shortest one. You don't just get to decide like, oh, this is on the the top or the bottom of the stack. The whole point of Dijkstra's is to take the shortest path. So that's why you take the 8 here, which is Pueblo. So it should make sense to you guys. I don't think I need to explain anything else.
Well, it's kind of like discrete mathematics, our last week of it.
Yep. It's the same thing, isn't it?
Yeah, but I would
Except
say
they throw in-
that we're pretty much done with these worksheets.
Boom. Nice job, Zach.
It wasn't too bad. You guys are doing the hard stuff right now.
Yeah, we're doing pretty good too. So
Christian, we're gonna need your help with assignment 6.
I need to look at it first.
All right.
I'll look at it later. I mean, I gotta put the kids to bed. I was gonna look at it tonight.
Cool.
Okay.
You have to read them a bedtime story too.
And sing songs and stuff.
Yeah.
put them on. We'll all sing them a song.
It's okay. Hey, Owen. Come here.
You guys know Pirate's Life?
No.
Yo, yo, a pirate's life for me.
I know that one. I just don't know the words.
I don't either. They all knows.
Alright, I'll be right back.
We're supposed to
Okay.
sing some really horrible, shocking song,
Well,
you know?
I think we're hanging up now.
Okay.
Let's just get back to the assignment.
Assignment. Sounds good to me. Thank you, Zach.
All right. Good job.
You, what you need to turn
Thanks.
everything in.